1, 2, 3.
This podcast is brought to you by Red Engineering and Design, the engineering firm that provides practical solutions to complex structural problems. Columns are considered the legs of a building. They transfer loads down to the lower levels or to the ground. A perfect column, under a load perfectly centered, will hold the weight until at a critical level and then snap sideways and buckle. But columns are not perfect, and loads are rarely centered on top, so the buckling of columns is a bit more complicated. Leonhard Euler, an 18th century mathematician, first accurately described the buckling behavior of columns. He found that a column's capacity to carry a load is dependent only on its height and stiffness. A taller column will buckle at a lower load than a shorter one, but the stiffness is a little less obvious. How a column's top and bottom are attached affect this stiffness. If a column is fixed at the top and bottom and not allowed to move or rotate, a column behaves as if it is half of its actual height and is capable of supporting up to 4 times its normal load. But a column that is fixed at the bottom and allowed to move freely at the top, much like a flagpole, it behaves as if it was twice as tall, thus able to support only about 1/4 of the normal load. And hopefully that gives you a leg to stand on. Follow us at redengineeringdesign.com or brianmosco.com.